All right, video for the honors semester 1 exam review. First thing you might want to do is you might want to pause the video, use these answers, double check your work to see if you got them right or wrong, and then that way you may not have to watch the whole video. You could just kind of go to the spots that are important. So I'll scroll down, let you pick up the bottom ones here. All right, so after you've paused that, you can go ahead and start fast forwarding through, and I'm just going to go right in the order that we got here. See if I can get two at a time. Maybe make this a tad bigger. All right, so let's get after it. So number one, going through here, the big thing you need to know is that these distances need to add up to be the whole line. So the distance from Q to R added to R to S has to equal the entire line, all the way from Q to S. So I'm just going to plug values in here. QR is -1 plus 3x. RS is -4 plus 2x. And QS is the big dog here. QS is 10. So we're going to combine some like terms first. So let me gather up my x's. I have 3x and 2x, so that's 5 x's. Then I have my numbers or my constants. A -1 and a -4 make a -5. Now I can start solving both sides. I add 5 to both sides. And then I divide both sides by 5. And we get x equals 3. All right, moving on over here to number 2. I need to do the same type of thing. So I'm going to kind of maybe speed this one up just a little bit. So instead of writing down, actually I'll just write it. It won't take long. JK plus KL equals J to L. So I have 2x added to 18 plus KL is 7 equals the whole line. And now I start doing my algebra. And so I'm going to gather some like terms over here. So I have 2x added to 25 equals x plus 18. Subtract an x from both sides. It's going to give me x plus 25 equals 18. Minus the 25 from both sides. And I may not always show that stuff. I'll just kind of do it. So I'm assuming you got your algebra down by now. So the correct answer there is -7. All right. Next one, let's go check out 3 and 4. So 3 and 4 are kind of similar, but a little bit trickier. We need to solve for x. So let's kind of try to figure out what we can here. So hold on. All right, I thought maybe I could shortcut this, but it looks like I got to work it out. So the key on this part is we need to find some of these missing pieces. So like the first thing I notice is I have a bigger dimension here. Like I have all of this is 18. All right, so basically these two added together need to come out to be 18. So whenever I have a total, and then I have this smaller piece right here, I can use subtraction to find EF. You know, so if I wanted to write this out, I'll just do it one time. This is a true statement that the distance from E to G equals, or check that, the distance from E to F, what I'm looking for, should be equal to EG minus FG. So it's kind of like the total minus the piece on the right should equal the piece on the left. So when I set this up, you know, I have my 18 as my big piece. Take away FG, and I got to make sure to put that in parentheses. That should equal EF, and I'm not going to get a number, but I'm going to get an expression. So it looks like EF is 18, and then basically we're just distributing the -1. So minus x minus 22, which makes EF equal to, that's -x minus 4. So I can now put that on the line here. This is -x minus 4 for that little chunk. Now I'm going to do the same thing for the other piece, for the other missing piece up top there. So the other missing piece on the top is, I need to figure out GH. Well, I'm going to do the same subtraction thing going on here. I have from F to H, this whole line right here is 17. So I think if I do the whole line, take away the piece on the left, that should equal the piece on the right. So if I do the whole line, take away the piece I know, that should equal the piece that I'm trying to find, GH over there. So we'll do the same thing, 17, I'm going to distribute that, minus x minus 22, which comes out to be negative x minus 5, not 55, negative x minus 5, eraser, and that should tell me what GH is. So I'm going to put that up top. I have a negative x minus 5. So now I'm in pretty good shape. Unfortunately, there's no shortcut for this problem. You just got to kind of rock it out how I'm doing it. Well, now I have all three pieces. So I know that the distance from E to F plus the middle segment, F to G, plus the end segment, G to H, should equal the entire line. And now I have all those pieces. So I have EF, I have FG in the center there, I have GH, which is on the right, and that's going to equal, and they actually already expressed E to H for me, it's just x plus 33. Now I got some algebra to do, I got to combine some like terms, I got a bunch of crap going on. So minus x plus x, they cancel each other, and then another minus x, so I have minus x. Now when I look at my numbers, negative 4, negative 5, that's a negative 9, added to 22, a negative 9 plus a positive 22, that's 13, equals, I got x plus 33 on the right, so I'm going to add an x to both sides. So add an x to both sides, I'm here. I'm now going to minus 33 from both sides, which will give me a negative 20 when I subtract 33. And then divide, and you get x equals negative 10. Now, if you're not sure, just plug negative 10 in and see if it works. So when I plug negative 10 in right here, I have a negative 10, which is really positive 10. Take away 4. I get 6 for this piece. Well, when I put negative 10 in for x, negative 10 plus 22, well, that's 12. And then when I put negative 10 over here, negative 10, take away 5, well, that's positive 10, take away 5, equals 5. So I believe I got all the pieces, because if you check this out, 6 plus 12 does equal 18. And then 12 plus 5 does equal the 17. So nasty problem. I don't wish it on my worst enemy, but you got to do it. So here we go. Let's get after this one. This one's a little easier. I'm looking at this thing, and I see I have a total of 9, and I have a little piece that's 7. So I can use subtraction. 9, take away 7 is going to hook me up with a 2. So that was a lot easier than the last problem. Well, now to find this piece, I'm probably going to have to use another dimension. So maybe I use this dimension right here. This is the entire distance from U to S. So I'm going to do the entire distance, 2x minus 3, and then I'm going to subtract, 7, subtract this piece, and the leftover should give me what's right here, because the total minus the left piece should equal the right piece. So the total minus the left piece, this is just 2x minus 3 minus 7, which is just 2x minus 10. All right, so I'm going to write a 2x minus 10 in there. And let's kind of see what shakes out now. Getting rid of all this crap. I do have the total, so let's just add up all three pieces. So VU plus UT plus this dude should equal the whole line, should equal all of that, which is x plus 9. Well, now we got to gather up some like terms, do our stuff. So I have 9, take away 10, so that's 2x minus 1. Over here I have x plus 9. Subtract the x from both sides, minus that x, minus that x. I get x minus 1 equals 9, add the 1, and I get x equals 10. Plug it in, see if it works. So 2 times 10, take away 10, that's 20 minus 10. So I have my pieces 2, 7, and 10. And when I plug 10 in here, it says the entire line should be 19. Well, 2 plus 7 is 9, 9 plus 10 checks out. Those problems are just time consuming. 5 and 6. Oh man, these ones are going to go really fast. Get a nice little breather. So 5, this is less than 90 degrees. So this is acute. This is greater than 90 degrees. So bigger than 90. So that one's obtuse. Now we're starting to move quick. Name the angle in 4 ways. All right, so we got to name these angles. Well, the easiest way is just call it angle 3. Next easiest way is name it by its vertex. Just call it angle I. Then, if you're going to use the 3-letter combo, you got to put the vertex in the middle, but you could either call it HIJ or you could call it JIH. Either way. So similar idea for number 8. Call it angle 3, call it angle R, call it angle SRQ, or call it angle QRS. Those are the 4 ways. Keep right on going. So this is angle addition postulate. Basic premise here, just kind of off to the side, is that if you have 2 angles, let's just call this angle 1 plus angle 2, you should be able to get how much the big dog, angle 3, is worth. And then you can also use subtraction if you know the total in one of the 2 pieces. So that's what I'm going to do here. So let's label our picture. RST, well that's this big dog, R to S to T. So that's the whole thing is 136 degrees. And RSJ is this little fella who's X plus 19. And then we have JST, joust. JST is chilling right here. And that's 10x minus 4. So basically, our setup is going to be little plus little equals big. So the little plus the other little equals the big dog. And now we just got to do some algebra. Combine like terms for 11x. Add 15 equals $1.36. Take away the 15 from both sides. And we will get, what's that, 121 divide. Looks like x is going to come out to be 11. All right, probably similar idea over here for number 10. So I got a big key is label my angles. So BCD, well that's the big dog. B to C to D, that's all of this, is going to be 21x. So I know that's going to be over here on the side by itself on the equal sign. So now I got to get the other 2 angles here. And let me see, HCD, so that's the one on the left. HCD is the 12x plus 8. And then the one on the right, BCH, uh-oh, that's a bad word. BCH is 55. So we have the left plus the right equals 21x. Let's clean this up. 12x's plus 63 equals 21x. Minus the 12x from both sides gives me 9x. City 3, divide, x equals 7. Money. And you could plug it back in if you really needed to, but I trust myself here. So let's keep on going. Now, multiple choice can make it a lot nicer if you have multiple choice, so you can see if your answer's chilling there. All right, so number 11. First thing I notice is this red box. That means I have a 90 degrees. And this is a straight line, so they should all add up to 180. So if this is 44, there should be another 90 over here. So if I do 90, subtract that 44 degrees, means I'm missing 46 degrees right here. So I know what this is, but I still got to figure out what x is. So when does 4x plus 2 equal 46? Well, minus 2 from both sides. Divide by 4. And I get x equals 11. All right, moving right along. Number 12. I see 2 angles. They actually form a straight line. So this right here added to this right here complete a semicircle. or they're called a linear pair. So this is the linear pair theorem. Add up to 180. So angle on the left plus angle on the right got to equal $180. Combine some like terms. 3x's, combine numbers, minus 33. Whoa, that's ugly 8. Do a little math. Add the 33 to both sides. That's 213. 3 goes into there. 71. X equals 71. Now, just double check. Yep, we want x, so we're done. Sometimes they want me to actually find the angle, so I may have to go back and plug that in, but not on this one. Keep on going. Number 13. All right, so 13, some quick refresher. Parallel lines. All right, whenever you have parallel lines, you're going to have 4 angles that are all the exact same. All right, so I'm just going to call them dots there. And then you're going to have the other 4 angles that are all the same. All right, they all match. And then the key thing that you need to know is that every dot plus every dash has got to come out to be 180 degrees. Now, you can memorize all the names of the pairs, and I'll name them as I go. But you got to realize, are you acute or are you obtuse, and are you the same, or do you add up to 180? So looking at this pair here, you know, if I kind of go dot, dot, and then copy, paste, I'll notice that one is a blue and one is a red. So they cannot be equal to each other. So they have to add up to 180. So I have 13x plus 4 added to 8 plus 11x. You got to add up to 180. This pair is actually called consecutive interior or same side interior if you're into the names. So we got to combine some like terms. We got 24x's. We got 12 equals $180. Minus that 12, looking at 168. Divide, it's got to end in an 8, so it looks like it's got to be a 7. X equals 7. Solve for x. Bam. We are done. All right, next problem. So if I play my little game, you know, dot, 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 and then I come the other way. Red, 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 red. Oh, these are both reds. Now, they're actually alternate interior angles. It's good to know that, but you can play the dot game with colors. So these two are equal to each other. They're not adding up to 180, they're equal. Congruent, so to speak. Boom. So minus 8x from both sides. You gone, and I get a 2x. Hey, what the heck's going on here? Got an extra x in there. It's not supposed to be there. All right. So put my minus 2. And then I got to add 2 to both sides. So 18 is 2x. Divide by 2, divide by 2. X equals 9. So chilling there. Let's go to number 15, 16. Boom, boom. So 15 and 16. Same idea. So these two actually are, you don't even need the top line. These are vertical angles. But blue, blue. Well, hey, I said blue. Blue, blue. Blue, blue. So they're both blue, they're equal. Vertical angles, 10x minus 10. It's got to equal 8x plus 12. Minus the 8x from both sides. Add the 10 to both sides. And you get x equals 11. And again, I'm not showing all the algebra steps just because with the honors, I assume you probably got this. So again, blue, 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 blue. We got red, 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 red. Hey, those are both reds, so they're equal to each other. Actually, they're called alternate exterior because they live outside the parallel lines, and they're on opposite sides of the transversal. So 76 equals 7x plus 13 minus 13 from both sides. I'm looking at 63. Divide, divide. X equals 9. We're crushing it. Bam. Keep on moving. Let's do this. All right. Find the midpoint. So you need a formula. I wouldn't recommend drawing this. It's going to take a while. So let's just use a formula. And the formula, I always think is you're going to average the x's and you're going to average the y's. Now what that really means when you average two numbers is you add them up and you divide by how many there are. Add them up, divide by how many there are. So One way you could do this, so let's look at our x's. We have an x and we have an x. Well, let's add them up. 6 plus 3 divided by 2, aka 9 divided by 2, which is 4.5. So there's the average of the x's. Now we do the y's. We add up our y's. 10 plus a negative 2, which is 8. 8 divided by 2 is 4. And that is our midpoint. 4.5, 4. All right, same thing. Let's just kind of go a little quicker over here. X plus x, 9 plus 9 chopped in half. Y plus y, negative 4 plus a negative 7 chopped in half. So that's 18 divided by 2 is 9. Negative 11 divided by 2 is negative 5.5. And there's our new coordinate. We are good to go. All right, let's try to get a couple more in here before the bell rings. 19 and 20. These are a little bit easier if you have graph paper. The problem is the points get a little bit far away. So I'll kind of show you a little cheat or a little shortcut to this one. So if you kind of think about it like this. So we have an endpoint. All right. So here's an end. And then we have a middle, which is 10, 3. And we need to get the other end, which means it's got to be the exact same distance away. So here's how I play the game. I play the game and say, how far is it from that x to that x? You know, what's the distance? On a number line from negative 2 to 10, well, that's 12 spaces. I added 12 to that number. So I need to make the same hop again, and I need to add 12 again. So 10 plus 12 would put me at 22. Now, I play the same game with the y. From 3 to 3, oh man, that was a hop of 0. So I got to make the same hop of 0. So I believe that answer is going to be 22. Oh, crap. Hold on, I screwed this up. That was a negative 3. Check, 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 check. All right, back it on up. That was a negative 3. So a hop from a negative 3 to a positive 3 is 6. So then I got to hop another 6. I thought that was kind of weird. And that's going to hook me up with 9. All right. Now, you could put it on a grid and do like a slope kind of thing. But I think for an exam where time is an issue, this would be the best way. So let's check this one out. End, middle. How do I get to the other side? Let's play the jump game. Negative 8 to 9. Well, that's a jump of positive 17. So jump another positive 17. 9 plus 17 is 26. Now let's jump the y's. 2 to 5 is a jump of 3. You don't always add, though. You might subtract, so just be careful. Jump another 3, and we're talking about the point 26, 8. All right, 21, 22, find the distance. So whenever I do distance problems, I always use Pythagorean theorem. So legs squared plus legs squared equals hypotenuse squared. Or most people just refer to it as a squared plus b squared equals c squared. Well, all of these lines, we're trying to find c. We're trying to find the hypotenuse that's across from the 90. So I would just draw a couple legs. So I draw a leg here, draw a leg here. Make a right triangle out of it. This side's 3, this side's 4. This is a nice little triple. Hopefully you just know 3, 4, 5. But if you don't, you do leg squared plus leg squared equals c squared. Take the square root of both sides, and I get the square root of 25 equals c. So c equals 5. Number 22, make a right triangle. Bam, bam. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 squared plus 6 squared equals c squared. Square root of that side, square root of that side. C is radical 72. Depending on what you want to do, some people might want you to break this down and simplify the radical. So I could break this down into the square root of 9 times the square root of 8, which would be 3 radical 8. But then I can break down radical 8 and do 3 times radical 4 times radical 2, which would be 3 times 2 times square root of 2. which is 6 square root of 2. And there's other methods, other tricks. But if you just need the decimal, you got to actually, punch that into the calculator, which I'll do really quick. Let's see, square root 72, bam, about 8.48. So either one of those answers, any one of those three answers would be good to go. All right, let's keep on rocking and rolling. 23, 24. Hold on, did I skip something? 23 and 24. So now we're getting into slope. So key things about slope you need to know. Increasing left to right, positive. Decreasing left to right, negative. Flat line, 0. Vertical line, undefined or no slope. So have an idea of the sign before you even get started. So for instance, number 23, I know this is a negative slope. Now, my fraction, remember, you can think of it as rise over run. That's a good way. I like to think of it as the vertical change over the horizontal change, or the change in y over the change in x. There's a lot of different ways to look at it. But basically, these two dots, I have a vertical change of 2 and a horizontal change of 3. So, correct slope here, negative 2/3. Now, if you're just given the coordinates, there's a nice little formula. Slope is subtract the y's over subtract the x's, which the Greek letter delta just means the change in y over the change in x. You can use the slope slide, so that's kind of fun. Not really, but whatever. So these are my x's, these are my y's, and basically I'm going to subtract these two y coordinates. So I'm going to go 3 take away 6, and I'm going to subtract my x coordinates on the bottom. 16 take away 6 for negative 3 over 10, and just yank that 3 out to the front and call it negative 3/10. All right, keep on going. Boom, boom, 25 and 26. So one of the big forms you need to understand is y equals mx plus b, slope-intercept form. So the number in front of x is the slope. This back number is the y-intercept. And that's only if it's in y equals form. You can only use that number in front of the x as a slope if it's in y equals form, which this one is. So the slope for this problem is simply negative 2/3. Find the slope of a line parallel. Well, parallel lines need to have the same slope. So when I look at this line here, x equals 2, well, it's a weird line. X equals 2 is a vertical line that crosses at 2. And notice every single ordered pair on that line has an x value of 2. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. It's always 2. So this line, since I need to keep the same slope, this line has a slope that is undefined, or some people might say that it has no slope. So vertical lines, undefined, parallel. Next, boom, boom. So find the slope of a line parallel. We can do that. So again, parallel, keep it the same. This guy has a slope of 2, so I got to have a slope of 2. Now, perpendicular. Perpendicular, the slopes are not the same. So the key idea you need to understand is that one line is going to be positive, the other line is going to be negative. All right, coming down. That's going to give me that perpendicular 90-degree angle. What really happens is you need two things. The two slopes need to be opposites, meaning one's positive, one's negative. And then they also need to be reciprocals of each other, or flips, if you will. So, this dude, this line right here has a slope of negative 1/3. So if I want to be 90 degrees or perpendicular to this person, I need to flip it and change his sign, which on a multiple choice test will just be positive 3. They won't put the 3 over 1. All right, let's keep on going. 29 and 30. So 29 and 30. Y equals 5/2 x. Find the slope that's perpendicular. His slope is 5/2. So I need to flip it, change the sign. All right. Write slope-intercept form of the equation through the given point. So I always start off with, I need to get this in y equals mx plus b form. So the two things that I need, whenever I want to write the equation of a line, I always need the slope and I always need a point. All right? I need some sort of xy that I can plug in. So if I notice right here is my slope chilling. So I'm gonna call this my starter equation. Y equals the slope times x plus b. Now I got a problem. I don't know what b is. So what I'm getting ready to do right now is I'm going to solve for b. And how I do that is I take this x and I jam it in, and I take this y and I jam it in, and I solve for b. So we got -5 equals -3/2 times 4 plus b. And you either got to do fractions on your calculator or know how to do them by hand. I'm going to call this 4/1 because it's easy to just multiply straight across. So I get -5 equals, well, that's a -12 divided by 2 plus b. So that's a -5 equals -6 plus b. Add 6 to both sides, and we find out, oh, sweet, b is 1. So now I can complete my final equation. My final equation is y equals, we know what the slope is. I knew that from the beginning. But now I know what my b is, and we are money. We got our final slope-intercept equation. All right, 30-31, or 31-32. So write the slope-intercept form of the equation that goes through those 2 points. So I need to get through those 2 points. So again, I need slope and I need a point. Now, luckily here I have 2 points, so it's kind of dealer's choice. So get your generic start. Y equals mx plus b. Well, I need the slope, so let's find it. We just did that a few questions ago. So remember to find the slope. It is, you can use the slope slide if you want. So 3-1, 5-2, woo, go down. So 1 take away 2 on top, -3 take away 5 on the bottom. That gives me a slope of -1 over -8, which is just 1/8. All right, so I have a slope of 1/8. Up 1 over 8. So let's put that in here. So y equals 1/8 x plus b. Well, now I'm going to use my point, and I pick either one I want. I like to pick the positive point if I can. So since this one has 2 positive numbers, I'm going to do that. It's kind of 6 and 1/2 dozen the other. So 2 equals 1/8 times 5 added to b. So 2 equals 5/8 plus b. So I'm going to subtract 5/8 from both sides. And again, here's where you better use your calculator, or if you're good with fractions, if you're old school, like me, I know that 2 is the same thing as 16 over 8. So I'm going to use 16 over 8 because 16 take away 5. That gives me 11/8. So now we can finish the problem. We know the slope. And we know the y-intercept. And it might show up as a mixed number. I don't know. So maybe it shows up like that. We kind of cheat here, and I'll peek over at the answer key. Just see what form it's written in. Hopefully we did it right. It looks like the answer key was left as an improper one. So good to go. All right, 32, same game. Except for, again, always think I got to have the slope and I need a point. Now, they don't give me the slope, but they say I'm parallel or I'm the same slope as this dude. So basically, they give me my slope. So starter equation, y equals slope x plus b. Now we use the point. Jam it in. Boom. boom, plus b. We start cranking this thing out. That's like 5 over 1. So that'd be negative 15 over 5, which is negative 3. Add 3 to both sides. Add 3, add 3. B is negative 1. So now we're ready to finish it. Y equals slope x. B is negative 1. Money. Next. Boom, boom, boom. All right. So same game. I need slope. I need a point. Now we got to be perpendicular. So I need to make some changes. His slope is 5. To be perpendicular at 90 degrees, I need to flip it. Now you can't really flip it unless you put a 1 under it. Now I can flip it. But then I got to change his sign. So we now know our slope. Our slope is negative 1/5. So y equals negative 1/5 x plus b. Time to solve for b. We're going to jam that in there. Boom. We're going to jam that in there. Boom. Plus b. Negative times a negative is a positive. 1/5 times 5 is 1. So we get 5 equals 1 plus b. Minus 1 minus 1. B is 4. Let's close the deal. Y equals slope x plus b. Money. Aight. 34, classified by angles and sides. So let's do the angles first. Well, hey, they're all the same. I don't even got to look at the sides. If you're all equal angles, you're all equal sides. So this is equiangular. I don't think I spelled that right, but whatever. Equiangular and equilateral. Sometimes they just write equilateral, but everything's equal. Keep on going. Bam. 35. Solve for x. All right. So key on this one is this is the triangle sum theorem, which basically says, hey man, all triangles equal 180. So right now I add up what I got. And a couple different ways you could do this. You could just add all 3 of them together if you want. So I say, hey, 61 plus 37 plus x plus 93. All 3 of those angles got to be $1.80. Gather like terms. 61 and 37 is 98 plus 93. 98, 93, 191. And I have an x in there. I got $1.80 minus negative 11. Now, another way to do that is, another way you could bust this out is you could just add these 2 up and say, well, that's 98. And then don't even look at that for a minute and just figure out what that angle is. So you could subtract from 180 and you'll get 82. And now I'm like, oh, okay, 82, you're supposed to equal x plus 93. And now you just minus it from both sides. Same answer, either way, it's your choice. All right, number 36. If you're making your cheat sheet, you're going to want to have the exterior angle theorem, which basically says if you have a triangle and you extend a side like this one, you create an exterior angle, which I'll just call x. There's an equation that says x, that outside angle, is always equal to the 2 far away angles. They're called remote interior, but the 2 far away angles. So I'm going to use that same idea right here, and I'm going to say, all right, my outside angle, x, equals my 2 far away ones added together. 2 far away ones added together. And so we break this down, and I get 111 equals 8x plus 31. And then we minus the 31 from both sides, and we get 80, and this is going to work out really nice. Divide. X equals 10. Bam. Keep on going. Crank this out here before lunch. All right, 37. Determine if the 2 triangles are congruent. If they are, state how you know. So remember, how you know is side, 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 angle, side, angle, side, angle, 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 side. And then there's this weird one called hypotenuse leg, which only works with 90-degree triangles. Now, the two that don't work, A double crooked letter, bad word, and AAA, booty insurance, does not work. All right, so don't use those two. Well, let's see what we got going here. I look at this picture, and I only see two markings. I see an angle and a side, but then remember, vertical angles are always equal. So I'm going to just kind of pick one triangle. I'll pick this bottom one. Let's just focus on its markings. So we have this angle, we have this angle, and we have that side. So it looks like, I got to be careful here, but I have an angle and another angle, and I do have the included side, the side that's trapped in between. So this is ASA. This is in chapter 4, Congruent Triangles chapter. Well, these two are pretty easy. I have two sides with the A in the middle, so this is a good old-fashioned side angle side. Let's check out 39 and 40. Determine if they're congruent. It's the same idea. So I see a vertical angle that they didn't tell me about. So now I'm checking this out. I have an angle, I have an angle, and I have an angle. And 3 angles is not good enough. That's AAA. So these are not necessarily congruent. They might be, but they might not be. All right. You may have a little version on one side and a big version on the other. All right. What else we got going over here? Let's see. I see an angle, I see an angle, and I see a side not trapped in between the two angles. So this would be angle, angle, side. Keep on rolling. Rolling, rolling. 41. So the measure of angle 2 is x plus 57. I like to right away get rid of this 2 right here. Just get rid of that. And just write in there x plus 57. That's how I like to do these problems. I think it's a little bit easier. So really what's important right now, getting rid of all the crap that doesn't matter, is I have a 45 degrees and I have an x plus 57. Now, isosceles triangles. There's an isosceles triangle theorem that says if two legs are equal, if two sides are equal, the angles opposite them, they kind of point to them, also have to be equal. So set up an equation. X plus 57 equals 45 minus 57. You're going to figure out x equals negative 12. Next one. So again, I don't like it when they stick this little 2 in there. I'd rather see an x plus 83 chilling in there. Well, this is like a double isosceles triangle. So a lot of clues. So let's first focus on this triangle right here. And focusing on that triangle, I see two sides that are equal. So immediately I got to find the two base angles that are equal. So that means this angle and this angle are the same. That allows me to find this vertex angle at the top. So I'm going to add those 71s up, and I get a buck 42. Take away from 180 in a triangle, and I get 38 degrees. Now the red box comes in handy, but because the red box says, hey, this is a 90-degree angle. So do 90 minus 33, and that's going to hook me up with 57. All right? But look what we have over here. On this side, I have another isosceles triangle with two congruent sides, which means this angle and this angle have to match each other. So you're 57. So now I have two 57s, and I should be able to figure out what this is going to be. So let's add my two 57s. I got a buck 14. Subtracting from 180, that means I have 66 degrees left. But they're like, wait a minute, we say it's x plus 83. So you say it's x plus 83, I say it's 66. I minus the 83 from both sides, and it looks like x is negative 17. All right. 43, 44, same idea on this one. So let's bust this out. So I have a 119. These two right here form 180, straight line. So 180 take away 119 is 61. I do have an isosceles triangle, so let me just quickly get rid of this stuff that doesn't really matter. So I focus on this triangle right here, and these two equal sides mean these two angles are equal. So I have those two. 61 and 61 is 122. Subtract from 180. Leaves me 58 here. Play the 90 game. Subtract from 90. That gives me 32. But now I have an isosceles on this side, which means that this little angle and this little angle have to match each other. So 32 is the oddball. So if I do 180 minus the 32 in the vertex, it means I have 148 degrees left. But I need to split that between the twins. So divide that by 2, and I get 74 degrees each. So you're 74, angle 2 is 74. But they're like, wait a minute, I now know what the measure of angle 2 is, it's 74. So when does 74 equal x plus 84? Minus 84 from both sides. And you figure out x equals negative 10. All right, 44, now we're getting into chapter 5, special segments. Because of the markings, this is a mid-segment. So NM is a mid-segment. Now, a couple things about mid-segment. A mid-segment is always parallel. So I know that segment NM is, check this, NM is going to be parallel to PR. Jeez, oh Pete, I'm having trouble spelling here. NM is parallel to PR. And then I also know that it takes 2 NMs to make a PR. Or another way to say that is NM is half of PR. It's half as long. So I don't usually use the half one because I'd rather not use fractions. I like to double the small. So basically the idea is that 2 mid-segments equals the opposite longer side. So 2 mid-segments has got to equal the long side. So let's distribute 2x, 34, x and 27, minus x from both sides. Bam. Minus the 34 from both sides. And it looks like, whoa, we're going to get negative 7. All right, keep on going. I know I'm going fast, man. You may have to slow me down, put me on 0.5 speed or 0.75 speed, or just pause. But I'm trying to rock this out. So RQ is the mid-segment. So it's going to take 2 RQs to make 1 DF. 2 RQs to make 1 DF. So it's going to take 2 of these jokers to make 1 of those. So distribute. Boom, boom. 34. X minus 1 minus x is 3x. Add 34, it's 33. Divide, x equals 11. Sweet. You can plug it in, see if it works. I trust myself. Hopefully. Let me see. 2 times 11 is 22, minus 17 is 5. 11 minus 1 is 10. Yep, 5's half 10, we're good to go. 46, find x. All right, where is x though? Measure of angle 1 is x minus 3. So you are really x minus 3. And the other one, x or ywx. All right, be careful here. ywx is the big dog. ywx is all of that, okay, which is 13x plus 6. And we have an angle bisector. So basically we know that angle 1 and 2 equal each other. So one way to do that is just say, hey, this dude is also x minus 3 because they're the same. So I add up the 2 small angles. So I have x minus 3 plus another x minus 3. It's got to equal the big dog. Or an easier way might have been to say, hey, 2 of the small angle equals the big angle. Either way, it should come out to be the same. You should get 16x's minus 6. Okay, I got that from distributing, or I could get that from combining like terms. Either way, 16x minus 6. Minus 13x from both sides. Add the 6 to both sides. Whoa, wait a minute. Oh, I don't know where the 16 came from over here. I was about to get a decimal. Get a little nervous. Add 6 to both sides. You get not 16. I would have got 12. hold on. 6x minus 6, I subtracted 13. So that gives me 6 over here. And then add 6 to both sides gives me 12, which I'll have x equals 4. And you can plug it in, see if it works. I'm not gonna. 47, 48. One or more of its medians. So median basically says you take some sort of triangle and you go from a vertex to the midpoint. All right, you go right in the middle. So that's what we have. DH, so this little piece right here is -3 plus 3x. And then DG, this side, is 2x plus 1. And if you're a median, that means you split this side in half. So those two have to be equal to each other. So 2x plus 1 has got to be equal to -3 plus 3x. Minus 2x from both sides. Add 3 to both sides. And you get x equals 4. And if you plug it in, 2 times 4 plus 1 is 9. And -3 plus 12 is also 9. So it checks out. Life is good. All right, centroid. So let me see here. Centroid is what happens. It's where all the medians meet. So the medians meet at the centroid. So let's kind of find the medians. So I'm going to find the middle of every side. I'm going to bust out my big meter stick here to keep things straight. So the middle of each side, well, the middle of this side is going to be right there. So I'm going to connect that, and I'm going to come down. That one was easy because that line's horizontal. If I want to find the midpoint of IJ, so if I need to find the midpoint of segment IJ, I got to use that formula that we did earlier here. So, you know, point J is at, what's that, at 2, -8? So 2, -8. And I is chilling at 5, 0. So remember, midpoint is I add the x's and divide by 2. And then I add the y's and divide by 2. So we're talking 7 halves, which is 3.5. And that's -4. So 3.5, -4. So let's see where that is. So over 3.5, down 4 puts me right there. So here is another midpoint. So let's connect the midpoint with the opposite piece here and try to get this. All right, well, that's kind of ending up in a pretty nasty spot. So I'm not sure if you guys had to do these algebraically or if you're just going to be picking an answer out of some multiple choices. Let me kind of peek at the answer key. Because right now I'm thinking it's going to be about 2-ish and then down -2-ish. I mean, there is a way to do some algebra, but I really don't want to do all that if I don't have to. So let's kind of see. 48. So the answer key says 7/3 and -8/3, which is, you know, if you translate that, that's 2.3, so that's 2-ish. And this is -2.6, so that's -2-ish. So I could have got the right answer that way. So hopefully this one's multiple choice. If not, then, you know, we got our work cut out for us. There's a lot more to do, but I'll kind of get clarification on whether or not that's going to be multiple choice or not. All right, let's keep on moving to number 49. Again, find the centroid. So centroid, got to get my medians here. So let's find the middle of, I always try to do the easiest side. There's the middle of that side. So let's line it up piece to piece. Let's see what we can get here. We got that. Now I need to find the middle of another line. So I don't know. I like to use 0, 0 if I can. So let's try to find the middle of xz. So x is at 2, 4. Z is at 0, 0. So the average of the x's, 2 plus 0 divided by 2, that's 1. And 4 plus 0 divided by 2, so that's 2. So that one's not too bad. That's at 1, 2. So there's the middle. And we need to go to the far corner. So go to this far corner. And the centroid is where those two lines meet. So if I had to guess right now, this magic centroid point, to me, looks like it is going to be 0, 1-ish. You know, maybe 1.3, 1.4, I don't know. So let's just peek at their answers. Again, I'll have to get clarification on. If this is multiple choice, it should be an easy pick. I don't think the answers will be that close. 49, 0 and 4/3. So 0, 4/3, which is 0 and 1.33333. Repeating. All right, let's keep on going. Number 50. 50 and 51. So now we're getting into like the Khan Academy stuff here. So we need to do a translation. So remember, translations, if it's x plus, you're going to the right. If it's x minus, you're going to the left. I'd probably put that on my cheat sheet. And then if it's y plus, you're going up. And if it's y minus, you are going down. So we need to take all the original points, and it looks like we need to move left 1, up 2. So grab every point, go left 1, up 2. So I, left 1, up 2, you're I prime, you're the new I. Left 1, up 2, you're the new H. Left 1, up 2, you're the new G. Reconnect them. And you should have the exact same congruent figure, just slid left 1, up 2. All right, 51. So it looks like this one is going right 2 units and up 2 units. So right 2, up 2, you're the new U. Right 2, up 2, you're the new V. Right 2, up 2, you're the new T. Reconnect these jokers. And you should see, well, that wasn't connected perfect, but you kind of get it. Moving right along. Bam, bam. 53, 54. All right, reflection across the line y equals x. So y equals x, first of all, you got to know where that is. If you made a little table, a little T-chart, well, it basically says the two are always the same. 1, 1, 2, 2, 3, 3, which is all of these dots. So my reflection line is this 45-degree angle line that kind of comes all the way down. And hopefully you'll remember that there's a rule here that basically the x and the y's kind of trade places here. All right. So hold on one second. Sorry about that. Somebody at my door. So basically you got to know the rule. So the rule on this one is that every xy becomes, you just trade places. So the y jumps in front, the x goes to the back. So for instance, this point right here is at -1, 4. We got to reverse the coordinates and we got to go, so -1, 4 is going to go to 4, -1. So 4, -1. Cha-ching. So you're the new B. And C right now is at -3, 0. So you're going to become 0, -3. 0, -3. Boom. You're the new C. And the new A is at -5, up 3. -5, up 3. So you're going to be 3, -5, 3, -5. You are the new and improved A. Reconnect them. And you're good to go. Now, what should always happen when you visually look at this you should be able to connect the two B's, and your reflection line should be a perpendicular bisector. For every single point, should be a perpendicular bisector. Perpendicular bisector. That's what should happen if you're going to fold it properly. All right, rotation. So 180 degrees, you definitely want to write these rules down, but you basically have, let me fatten my marker a little bit. For 180, XY needs to become opposite X, opposite Y. Not necessarily negative, but opposites. So basically I put my points down. So I have F, I have E, and I have G. So F is at 1, 0. Be very careful you don't jack these up. 3, negative 1. And then G is at 2, negative 3. All right, so let's reverse these around. Not reverse them. I leave X and Y in the same position, but I change their signs. So negative 1, 0. Negative 3, positive 1. Negative 2, positive 3. So I just redo the rule. So left 1, 0. There's my new F. Negative 3, up 1. There's the new E. And negative 2, down 3. Boom, there's the new G. So the new G, the new F, and the new E chilling right there. It should be the same exact shape and size, but it's just rotated around a circle 180 degrees. So positive, so it went, and this one went half circle. All right, next one, just remember the rules, you'll be in great shape. So 55 and 56. So 55 is another 180. So same rule. So let's get our points. So we have E, we have F, we have G. E is at negative 1, 4. F, or not F. D is at negative 3, 5. And C, let me just redo these letters because I was going too fast. E, that's D, and C is negative 2, 1. And again, the rule for 180, and you better write down the other rules because I would expect there's going to be more than just 180 on that exam. So keep them in the same order but change the signs. 1, negative 4. 3, negative 5. 2, negative 1. So let's bust this out. 1, negative 4. Oh, check that. Not 1, negative 3. 1, negative 4. You're the new E. 3, negative 5. You're the new D. And then 2, negative 1. You're the new C. Reconnect them. Well, there you go. And should look the same. All right, dilation 1.5 about the origin. So from 0, 0, remember the origin's at 0, 0. So from this point, basically we're going to travel out this line. So the new V is going to be somewhere on that line. The new U, somewhere on that line. And the new T is going to be somewhere on that line. And now we got to figure out, well, 1.5 means we need to multiply the distance by 1.5. Sorry about that. I know there's someone at the door. So I need to go a distance of 1.5 further in every direction. So I kind of just, I don't know. There's a couple different ways to do it. But so like I kind of see that for, let's just say, for this distance, instead of going 1, I need to go out to 1.5. So I need to multiply that by 1.5. This distance is 2 by 2. So a 2 by 2, if I'm going to scale that up by 1.5, I need to go 3 blocks by 3 blocks. So I need to go 3 blocks by 3 blocks. I'm just going to put you out here. And then this is 2 blocks down. So I got to do 2 times 1.5. So I got to go 3 blocks down. And now I have my new and improved bigger version. If it's more than 1, it's going to get bigger. Less than 1, it's going to get smaller. But now I have a new one. And it should, all those lines should stay parallel to each other. And I now have a bigger version. So that's 56. Let's look at, last one. Outstanding. So 57. Let's check this out. We need a dilation of 3.5 about the origin. So I like it when it's about the origin. It just makes life easier. So 3.5. Well, right now, G is 1 block that way. So we need to scale that up by 3.5. So we need to go 3.5 blocks. 1, 2, 3. You're the new G. New G. And E00 doesn't move because I'm at 0 times by 3.5. I just stay at 0. F is, it's over 1, up 1. Well, I got to go over 3.5, up 3.5. You're the new F. So, and that little triangle there is exactly 3.5 times bigger. Hopefully this video helps you out, get you ready for your honors semester 1 exam. See you.